Okay, everybody, thanks for coming along tonight on such a wet and cold Melbourne night and battling the southeastern traffic, which is always kind of interesting. So hopefully when you leave here tonight, you'll understand a lot more stuff about roof drainage, which is a bit of the black arts, and also a topic which is becoming more and more of a problem out there in plumbing land. We see it a lot on new builds, and if you see driving around Melbourne now, all you see is like apartment buildings going up on every main road, covered in rain heads, covered in flat roofs. The biggest growth area of roofing sales for companies like Lysart and Stramit is flat roof for residential builds, but no one's really looking at the box gutters and rain heads that are attached to those, which are a big problem for buildings long term. Okay, so my name's Russell Kirkwood. I'm a licensed plumber and I'm one of the 4 directors of Dambuster. So tonight you're lucky enough to have all of us here tonight. So between us there's a wealth of information in relation to roof drainage engineering. Richard is a forensic engineer who has worked on all sorts of stuff in Melbourne and around the country for many years now. Rowan is also a forensic engineer. A lot of hydraulic stuff that he's done for Dambuster has been invaluable. And David's a chartered loss adjuster, so he's got a wealth of insurance background coming from seeing flooded buildings for most of his life. Okay, so between us, we are Dambuster, and yeah, we're going to give you a bit of a run around the Australian standards and what makes our products tick. So the very first thing, now the chances are, I just want to ask you a question before we get going here, right? How many of you guys put in box gutters and rain heads in your everyday plumbing, like, you know, in your companies? Yeah, we got fair few, like most of you are doing it. Anyone sort of doing solely roof plumbing work here or not? No, not really. Mostly, yeah, general. Yeah, okay. And like, if you were given a project, would it be pretty normal that you would carry out some calculations on that roof to see how much flow rate there would be on that roof? Do you reckon that you'd do that? And you know, it's a bit of an honesty question. Not really. I would have said the same thing. Like, engineers, you expect that to be done. You look on the plans. The plan says 600 mil box gutter. You just put it in. Yeah, exactly. And I would have thought exactly the same thing in about 2006 before I got involved in the insurance industry and then in Dambuster. So it's pretty normal practice that these things get done out there in the world of plumbing by rule of thumb. Or off the plans, which have been drawn up by supposedly someone who's thought about this stuff. What you find surprising is that they usually haven't. They've just dragged that picture from somewhere else and dropped it onto the drawing, and not much thought's gone into this at all. So what we've got up here on the screen is an amendment to a publication which I'm sure you're all familiar with, HB 39, 2015. Going to trade school, this would have been, you know, the handbook that you guys probably would have seen the most of in regard to roofing, flashing, metal roofing and cladding. So this amendment, which came out, was published last year on the 30th of July. Did anybody get has anyone heard of this before? No. One person. We knew it happened about a week after it happened, because obviously it affects our business, so we were watching the standards, okay? We contacted the VBA and we asked them, when are you going to tell anyone about this? Because when this particular standard's published in any way, shape or form, it becomes law immediately in Victoria. It's not like they have to put it in, you know, in 6 months' time or something. It becomes straight away law in Victoria. VBA have not told anyone about this. The closest they came is if you watch any of those performance solution webinars. I think it was one of us that asked the question. Yeah, Rowan asked the question. Wasn't me, was it? I can't remember. I was driving home, trying to listen to it and do things. Asked a question of them and said, is this enforced in Victoria now? And the answer came as like, yes. Okay. Now, nobody has explained that to anybody yet. We had a meeting with the VBA in December and they still said they were going to do it immediately, which obviously immediately doesn't mean immediately in the same way we understand it. So at this point in time, it hasn't happened. We believe it's imminent. So probably, it'll be tucked in one of the newsletters somewhere. Oh, by the way, this has changed. So it's going to affect you guys because, your standard kind of rain head installation that you see on every building in Melbourne, even though it tends to not even look like that, is kind of based on it. And this idea of dropping the rain head down to, they say 50% of the gutter depth, though it actually says flow depth there, which is two different things, has been utilised since forever, So now in the new world after this amendment, the only rain head design that you can use is the open fronted one from Australian standard AS 3500-3 and our rain head, the patented version. So that's a pretty big change. We don't think that the open fronted rain head is a hit with anybody. Okay, we look at that and go, it's pretty ugly. I'm starting to see them on buildings around Melbourne, and I'm like, I can't believe anyone wants that on their building. And we think that we've got a great alternative to that in Dambuster, which you can have a look at downstairs and feel and see that it's a really, really nice product. So that sort of drives where we go to from here. So the rain head's fairly simple part of the process. It's what's behind the rain head that we want to talk a bit more about tonight. It's the upstream stuff. So I'm going to run you pretty quickly through what our products look like, and then we're going to sort of swap over and have a look at a project that might be done with one of these things, with the Dambuster system, and then we're going to have a look at the handout which you've got there on sizing box gutters, which it's got all the calculations and formulas, and we'll sort of work through that a little bit towards the end. Finish up in about 40 minutes time hopefully, and we'll go downstairs and have a look. We've also got some videos which we'll show you at the end, which show our products in testing phase and that, and give you a good idea of what happens on a roof when it's pouring with rain, which we don't normally see. You see the after effects, but usually not up there when it's actually happening. So this is the Dambuster family of products. The rain head was the original product that we came up with, and it was all of this was devised not so much because we wanted to go into the metal roofing industry, but because all of us were looking at defective buildings in different ways, and we needed cost-effective ways to bring them up to compliance. And so this was built out of a solution, and then we realised that we had a business there that was servicing a need and putting out a solution for the plumbing industry. So you've got the original product, which is the rain head. You've got the free flow sump, which we'll talk about a little bit later, which is sort of an easier version of the high capacity sump in AS 3500, which if you've seen one of them lately on a building, please tell me because I'll go and take a photo of it because I've never seen one. And you've got the side outlets, which I think you guys will find really, really cool because basically it fixes this problem, which you probably all know, box gutters must be straight without change of direction. Now you see a lot of ones that aren't. But we've got a compliant solution. It does use performance solution, and we'll explain that how we've made performance solution really easy for you guys to utilise. They're a beautiful product. They're quick and easy to install. There's not much work there, and so there's huge time savings benefits for business in using these products. Quick look at a rain head. There's lots of cool features in this thing. Obviously, we've had this tested to death, okay? And all of the data behind this, it's enormous amounts of data that we've got to back up how these products operate. A lot of it was done at the facility up in Queensland at the AHSCA. Some of it is done in Melbourne in our own test rig, which we built, and then under a professor of hydraulics, which was Professor Robert Keller, is an associate of Monash University. So some of the features, just rush it through, but there's a seal on the back of the rain head. You'll notice that straight away. That's because that's one of the key spots that leaks into buildings. You know, you get big leaks there when you've got a gap, which, you know, half the time you've got silicon down the outside. I put my hand, when I'm looking at these things, I put my hand on straight in under the gutter. Where's the water going to go when it backs up? Straight into the wall, down into the parquet tray floor in Brighton, a couple of $100,000 worth of damage. Okay, so what we've done there is we've created a really beautiful seal on the back of the product, so that when this clicks onto the box gutter, and you have a silicon tight seal there with rivets running across. So that's one of the key benefits. You've got the internal overflow. Basically, we've suspended the requirements of Australian standards within an acceptable aesthetic, which will please your architects. You know, there's no holes in it. The only hole, as you can see, is the underneath, and yet it remains open fronted in the actual rainhead part. Just looking through, you can see, you know, the products are laid out there. There's the free flow sumps are a great invention, and what that basically is an internal rainhead. Okay, so rather than the box gutters having to flood and go out through an overflow, it maintains sort of the water running through in a way where you're not actually rising up in any way. So yeah, we've sort of made something there using Performance Solution to address a problem we saw in the industry. Elbows. The elbows are really handy. You know what it's like. You're looking at a plan, it's changing direction. How am I want to put a sump in that corner because that's the only way I can do it. But there's a girder truss right underneath it and I can't get the sump in. You don't have to now. All you've got to do is use a dam buster elbow, and the way we're able to change direction in a box gutter is because we change height. The problem with change of direction is that the water slows down if you just have it all on the same level, and all the crap from upstream washes down and deposits in the corner. So by using a change of direction, we're speeding the water up into the corner. There's turbulence that pushes the stuff through, and hydraulically it works. So that's what we've been developing with our professor of hydraulics to make sure that this is hydraulically sound and it works brilliantly. You've also seen over here, we've got a whole range of other things called which allow box gutters to enter from different directions. And so once we unlocked this idea of why can't you change direction, we were able to then develop other range of products which address this issue and give you guys flexibility on a building. So basically these things have been built with us trying to fix buildings. So at the moment, I don't think there's a building that we've been throwing recently where we haven't been able to go, yep, okay, if we use this product with this product with this product, we can achieve a compliant solution. This is an example of a building down on the Bellarine Peninsula. If I actually showed you this building, there were 16 changes of direction on the front face of a single story, you know, McMansion on the Bellarine Peninsula. There was flooding issues, all kinds of stuff. We got involved in this project. Rowan carried out some engineering calculations for this, and a plumber and building company came in, pulled it all out, used the dam buster system. What you can see there is you've got water coming down, dropping down into the corner, then dropping down again into the dam buster side outlet. So it's an elbow connected to a T, dam buster T, and into a rain head. All done under Performance Solution, which is a combination of DTS and Performance Solution. Okay, so and this works brilliantly. Without these products, we had no way of doing this. Trying to develop a performance solution and create data for this is an enormous task. And but with the data that we already have, we can provide you basically with our performance solutions are free. Come with the product. There's no cost to develop that. Now, this is all the stuff you need to know, but you don't need to know, okay? We've looked in great detail at the NCC. We've worked out how it works, where we can, how our performance solutions are based so that you can use our products with complete confidence. If there's any issues there, come back to us. We'll deal with the VBA. We'll deal with whoever on the basis that we're very ultimately confident that the system that we've put together is sound. Now down the bottom there it says refer to the VBA Part 3 webinar. I would definitely have a look at that. It's a good series and it gives you a better understanding of performance solution. But with the Dam Buster products, if you go onto our website, there are several documents on there which apply to Victoria, performance-based design brief, and a final report for performance solution, which you can use on your jobs, and we'll go through that a little bit later. Okay, a bit of Latin for everyone. Buyer beware in Latin. So currently, if you go off to, I don't know, Reese, Design Sheet Metal, wherever you buy your products from, you will have no guarantees that that product is in any way compliant, okay? Now, normally in plumbing, we buy products that have got a watermark on them, so we know that those products are fit for purpose, built from the right products, and they're excellent. You know, they can be used in a system. There's a whole bunch of stuff behind there that we never look at or think about. When you go into the roof plumbing world, nothing. A code, 3 or 4 handbooks that are sometimes very, very confusing and often contradictory, which you're meant to interpret and utilise. So when you come up with a deemed to satisfy solution for a house and you haven't done any calculations on it, which is pretty normal for plumbers, if there's a failure in that system, someone might come to you and say, can you show me the evidence of suitability for your box gutter design? In which the answer will be, I don't have any, okay? And from there, it sort of spirals downhill. So compliance is built around being able to show how you achieved it. And so we're going to have a look a little bit towards the end at how to actually size a box gutter. And we've tried to make that a lot easier using information you can get off our website. This is just talking about how basically our products are free flow. Once again, you know, the concept of free flow is that there's no backup in the system. So box gutters that run to rain heads are meant to flow without any restrictions, okay? They're not meant to lift up and flood in any way. They're meant to go. That's why they talk about the 25mm drop down for the weir. So you think, well, why do they do that? But then on a sump, that'll be up above the gutter. That's because a sump isn't free flow, okay? A rain head requires the water to keep going down, so it never slows down. So this has all been addressed by Dan Buster. What we're talking about here is the Dan Buster design charts, which we'll come back to. This is really cool. This is something that Rowan's done. So basically, if you try and size a rain head from the Australian standards, you will probably go a little bit insane, okay? There's graphs that run sideways and round, and you have to read them in all kinds of weird and wonderful ways. There's a 13 steps of pain called the general method, which repeats itself over and over and over again. And that's probably the reason most plumbers don't do it. It's just too hard. They tend to work off rule of thumb. So what we've created here is some tables which make life really easy, and a more in-depth look at them a little bit later. We've looked at the elbow, hydraulic design. So, you know, we'll just move on here now. The performance templates, which I've already spoken about. One of the big issues there is when you're going to use performance solution on any site, anywhere, you need to get permission from the owner or the key stakeholders, meaning if there's no owner as such, the builder, developer, you know, so you just need to make sure that they know when they hand you a set of plans, you need to be able to go, you know what, these have got side outlet box gutters on them. I can do this, but I'm going to need to use performance solution. So here's a performance solution template. Cut 2 pages, there's nothing to it. It's already filled out, you just fill in the details and whatever. You hand that to the owner and say, we can do it, but you've got to just make sure that you've given us permission to use performance solution, at which stage you can move forward with the process. So it's made life really, really easy. And once again, these are free on our website. So, you know, up until only a few months ago, we were thinking, oh, you know, we would sell these, all sorts of stuff. In the end, it just became easier to make them available with our products and just to go, right, we just want people to use the products and move forward this way. Okay, the design process for a performance solution, 6 easy steps, okay? So those easy steps are laid out, and that will keep you out of strife with the VBA. It'll keep you out of strife down the track if anybody's asking, where's your evidence of suitability? Have you done any calculations? So if you follow these steps, you will be safe and safeguard your business from any litigation in relation to this. The great thing about using the Dam Buster system is if you do this and say there was a flood on a building, most of the time when something happens, they haven't cleaned their gutters, we know that. People don't do it. They get up there every now and again. The problem is if they haven't cleaned their gutters, but the underlying box gutter and rain head sumps are non-compliant, the non-cleaning of the gutters won't matter at all, okay? But if the system is compliant and there's test data to prove it, then the problem becomes quite simple. They haven't cleaned their gutters. They haven't done maintenance. That's why, and you can prove it. So this is really important stuff. Okay, box gutter basics. They're the standards that everybody uses. In relation to this, you need to make sure that those standards are updated and whatever else. But being Master Plumbers members, you have access to these standards, which is great. And we're just about to cross over into the 2021 standard, which has some interesting stuff in it and some changes, which is well worth being over. So these are some basic fundamentals. The 25mm drop down to the overflow in a rain head is a really important measurement, and you'll see that in all of our products when we go downstairs and measure that we've got a 25mm drop down at all times. Right, so we come to this slide here. So this is really the nitty-gritty of sizing things, which we really need to get into. So let's just have a little bit of a quick look at this, and then an example, and then we'll have a look at that handout that we've sent out with you. So what you got here might initially look like a bit mind-boggling, okay, but it becomes fairly easy to deal with. And like I do this stuff every day, so I'll look at a roof and go, geez, what are the measurements on this roof? Oh, I've come up with, so many square meters. I turn that to a measurement for litres per second, which we'll show you in the handout. And as soon as it's turned to litres per second, everything starts to make sense in the Australian standards because it's all based around flow rate. So this is a Dam Buster T being utilised on a roof. And what we've got is, a box gutter that's 450mm wide by 6 metres long, and another box gutter that's 450mm wide by 5 metres long. So on an instance like this one, you have to get a flow rate that's coming in on both sides of the T. So in this instance, that's been worked out to be 4 litres and 2.5 litres. Now you add those two things together and you get a 6.5 litre flow rate. That flow rate is really important because that sizes the downpipe, okay? So the downpipe has to be sized according to the flow rate. And it also means that you can select, because you don't have to do any design work on our products, you just select the rain head that is appropriate, which in this case is a 300mm wide one. So even though the box gutter is 450mm wide, our performance solutions, as long as you don't exceed the flow rate, which is the maximum flow rate for that product, you can shrink the box gutter at the change of direction, which is really handy, particularly if you're doing like retro work, because you know what it's like. You turn up, someone's put a 600 box gutter in there. You can't put a 600 rain head on because it's ginormous, and you do the calculations on it, and you realise it's got 2 litres a second running into it. Okay, it's just crazy. They've oversized it. So in this instance, you can reduce that sole width using the performance solution, still be compliant, and use a smaller rain head. Okay, which is a real advantage of the Dam Buster performance solution. So you can see that we've also shown the depths of the box gutter and stuff, which we'll have a look at the formulas for that a little bit later. But that's a really good example where, we've picked the downpipe size as well over there. So 6.5 litres equates to a 90mm downpipe. So using the Dam Buster tables, you can size the downpipe, you size the rain head, the side outlet you don't size, okay? It's just, it matches the rain head, and therefore it's already sized as such, so you don't even have to worry about it. So that's like a nice little example of using a T to do a change of direction and keep yourself compliant, and that would apply to so many buildings in Melbourne. It's just right around Australia. And the reality is, let's face it, most blocks of land are rectangular, and therefore when someone builds a building on it, the building is longer than it is wide, and they don't want to put the box gutters on the front of the building. okay? Always going to put them on the side, and therefore, bingo, they're going to have side outlets. That's just how people draw things. So what our products do is, instead of going to the builder, sorry, I can't do the job, or you're going to have to change the roof design, you work with what people want to build, which are these boxes that they're into at the moment, okay? So that is the dam buster philosophy for dealing with what we see as non-compliance out there currently in the industry. You'll also note a little note down here: all box gutters designed for Q minimum. That's the amount of litres per second, 3 litres. That's an important thing to remember. That the Australian standards is from 3 litres to 16 litres. If you go and there's a front porch on a house and you do the calculations on it and it comes to 1.2 litres per second, you assume 3 litres. And that's because leaves, debris, all kinds of stuff still washes into the gutter. And therefore, even though you might have a small flow rate, or what appears to be a small flow rate, it doesn't matter. You have to size to the larger flow rate, which is 3 litres per second. Also, if you just think about it for a moment, it's per second. If I had a Coke bottle at 1.25 litres and I was squirting that into your lounge room every second, it's still a lot of water, okay? It still does damage. And so, yeah, you know, we're talking about large volumes of water, even when it looks like it might be a small flow rate. Okay, these tables are really important, okay? They make life really easy. We've taken the Australian standards, we've turned it into a single page, similar to something that, say, Lysart or Stramit might put out for their products. And so you've got your flow rates on the left, you've got your box gutter across the top, and all you do is match the two things up. And that gives you the upstream measurement depth of the box gutter. Now, I'm going to ask a little straw poll here, basically. What's the minimum depth of a box gutter? 75 millimetres. HB39 in action, isn't it? Okay, so this table over here, this is we say you don't have to use this anymore, but that's the table from AS3500-3. I'm going to use my laser pointer here. 600 box gutter, running at 3 litres a second. By the way, it took me a long time to work out how to read this table, okay, because it's confusing. 3 litres a second, you notice they all stop at 3 litres a second because the Australian standards doesn't go below. And you can't just follow the graphs down because the graphs don't actually just stay on the same curve. Well, there's the pointer. Oh, hang on. That's working so well. And then go across to the minimum depth of the box gutter. So we're under 100 mil. 75 mil.
You got to read up.
Read up?
You got to hit the 1 in 40 slope and then read up.
Oh, the 1 in 40 slope up here. Oh yeah, you got to follow these up. So this is terrible. So suddenly you end up in this patch up here where the two come together, just there. 75 mil. Hang on, but that's a 600 wide box gutter running at 1 in 40. Who puts box gutters in at 1 in 40? Oh, that's like that. It's 25 millimetres over a metre. Okay? So this thing's terrorising down the hill, and that's the only way you can end up with a 75 mil height of a box gutter, okay? Because it's based on flow rate. And then if you then just go for a moment and go, oh, you know, he's talking crap here. If you go down to a 200 wide box gutter and you do the same thing up to there, and then you run across here to 1 in 200. Where's 1 in 200?
On the left, the furthest one on the left.
Furthest one on the left, 1 in 200. So there, it's 96 mil, isn't it?
107.
107 mil.
You can see the chart.
Okay, 107 mil. So the minimum width of the box gutter is 200 millimetres, 3 litres a second, 107 mil on, that's the depth upstream. And if you're putting in at 1 in 200, you've got to add 5 millimetres for every metre downstream. So suddenly you go, every plumber in Melbourne, including me back in 2006, thought the minimum box gutter height was 75 mil. And it is, it's just for a 600 wide box gutter running down a hill, okay? So it's quite interesting, okay? So these are sort of traps for everybody, not just young players, traps for everybody that are in documents like HB39 if you're not going back. And what you'll notice if you look at HB39 these days, it says, go to AS 3500-3, okay, at this location. Same thing with our sumps. They're a bit easier. You only got water coming in from one direction most of the time. 6.5 litres. We use an indicator overflow. Really, that's on top of the Australian standards requirements, but the reason we've got that there is because people just don't clean their gutters, okay? And I want to know that it was overflowing and they didn't actually clean their gutters for months and months and months before anything happened. So this device here, really handy if you just come into a situation where you can't actually get a rain head outside. There might be a window or something which stops you actually being able to do this stuff. And so this is a great device for getting you out of strife with this sort of thing. Oh, that's minor. Okay, we've sized the downpipe chart as well. Okay, all this information's on the website. Chances are you're not going to use this very often, but it's there, okay? Okay, we come to the one and only design example in this presentation. This is a house this is hot off the press. It was done last week, okay? So this is a house in Montmorency in the outer northeast. This guy threw us this project. And he didn't want rain heads on the front of his house. He wanted to change direction in the rain heads and he was being told he couldn't do it. And so we got involved in this project and lo and behold, here's the drawings for it. So that's sort of that's what you see as a sort of finished engineering drawing, which is exactly how someone up the back said, oh, that should be the engineer's job. You're absolutely right. In a perfect world, this would come to you and you just go and buy these products and put it in, okay? That's what we would love to happen, but there is no requirement for that at the moment in Victoria, okay? It just doesn't happen. And so that's left up to the plumber. And, you know, the original drawings for this showed all kinds of weird, wonderful things that just couldn't happen, okay? So I think this is probably one of the most important slides that we have. So if you are designing a roof, you need to shade the areas of catchment. Okay, you need to be able to go, okay, that runs to this device, this runs to another device, and so you can add up those areas to work out where you're going to go with it all, okay? So this is a really important process that needs to happen if you're going to fulfill this role. Or if you guys are going, hey, I don't want to do that, you need to go and get an engineer to do that. In the past, that would have been quite expensive because they were starting from scratch, and most engineers that we dealt with had no idea how to do this, okay? However, with the Dam Buster system, we're trying to educate engineers as well and get engineers to use this system, which then makes it a lot cheaper to do. So a project like that, I think that was 4 hours work to do this job. So it's not super expensive to get this sort of stuff done. But, you know, there's no reason why you guys can't do this once you get a hang of it, okay? Okay, so at this point here, there's a few other projects that we've got, which you can see, these are real jobs, they're not made up. They're real jobs where Dam Buster is helping people out to be compliant and not have to change the entire project based around trying to be compliant. And they really like it because they know what they want to build, they just don't know the regulations or how to actually do it. And there's a couple more of those for you to have a look at. We're not going to do questions now because we're going to jump to the handbook. And just, it's not to the handbook, to the handout that we gave you in relation to how to size those roof areas, which is really important. Now, I'm sure you're like me, maths probably wasn't your strong point at school. And sometimes you look at a formula and you sort of go a little bit funny with it. But these formulas, once you get them in your head, actually they're real. The numbers make sense, and we'll just run you through how this is going to work. Okay. So you guys have all got a copy of this to take home, and we'll make sure that the master plumbers have this on their website and from here on in. And you know, this is something that you guys really need to know about. Okay, remember we had a sort of steps that you had to use. So determine the rainfall design intensity. Okay. rainfall design intensity is so, it rained a lot today, didn't it? There's a lot of water around today. Did it rain hard, do you reckon, today? No? No, it was constant rain, okay? So the interesting thing about rainfall is you go down to Tasmania on the west coast of Tassie, it rains every second day, okay? But Tasmania has a really low intensity rainfall. So they get this sort of, rain like we had today, where it just rains and rains and rains. But you go up to Queensland, it rains really, really hard. So, compared us to them, they're like off the charts, 350 millimetres per hour in some places. We, on the other hand, are hovering around 200 or just below it. That's the first thing you need to know is where am I? Where am I? Not just I'm in Victoria, but where am I in Victoria? Because there's different rainfall intensities for, in fact, every suburb, okay? Which is a bit mind-boggling. And the reality is, we gather all this data and it doesn't actually always make life easier. It makes life a bit harder sometimes because we just know more and more stuff. Determine the design flow rate in litres per second, and we're about to show you the formula for that. Design each box gutter. So each and every box gutter in that building, and you saw all those shaded areas, needs to be designed, okay? Is it a tiny little pissy box gutter? I've still got to design it for 3 litres a second, okay? I can't just plaster anything on there. Okay, what they want changes direction. That means it's going to be a performance solution. So I'm going to have to get the performance solution templates out and make sure that I get permission to do this stuff. The performance solution design brief, which you guys can have a look at. I've got a couple of copies of it. We can have a look on our website. You can go on there and download all these things off the technical section of our website. Have a look at them. And you've also got to keep the documentation. Currently, the VBA, in their great wisdom, are saying you don't need to put that on the 360 system. But we're saying, hey, well, that's a great idea till somebody dies, somebody disappears, and no one knows what the performance solution was. Okay, so really probably a good idea to upload that to the 360 system, even just for your own records, okay, to know it's there. And so all of this stuff here made pretty easy with the Dambuster the processes. Okay, so this chart here is from the 2018 standard, which has got Melbourne at 187 millimetres per hour. Now, the new charts are a bit more complex than that, and some of these have changed because they've just got more and more data. And strangely enough, even with the climate change stuff, a lot of these ARIs are actually going down, which is interesting. So that's one way that you can find out what the intensity of the rain is for any particular location. But if you want to be really, really amazing, which is probably asking people to do something that probably is falling into the engineering basket, you can go on to the BOM's website and you can actually use the longitude and latitude of that location, and you can determine what the exact rainfall is of that location in millimetres per hour. So what I would say to you, and this is just one plumber to a whole bunch of other plumbers, okay, is that it can be a bit overwhelming when you start looking at rainfall intensities and trying to work out where you are and how much they are. The reality is that if I ask you guys this question, this is probably the best way to explain it, is if you were asked to put a roof on a building at 1 degree, would you do it? No? Our roofer over here says, no way, okay? Is it ever a good idea to use products at their minimum? No, okay? Okay, exactly, right? So the same kind of rule of thumb that we all use applies here. So for instance, I used to say Melbourne was 187 millimetres an hour, and really you had to go to Mount Buller or Mallacoota to find somewhere that was off that chart, okay? However, with the new data, you can suddenly find a suburb like Montmorency, which is 195, who gives a stuff, really? But why be on the low side of it? Why not assume a number that's a little bit more? It's not going to hurt. And also, the sizing of roofs is a little bit complicated because you also need to size walls that are exposed to weather. The formula requires half the wall to be calculated as well, because that's a catchment area for wind-driven rain. So it's very easy when you're sizing a roof to miss something, okay? So put a bit of fat into your calculations. It's not going to hurt. You won't find that the products will suddenly not work. I'm getting a time call, but we'll be really quick here, okay? This is the basic formula. I do this every single day of my life, basically, which is catchment area times the once in 100 ARI, which is the rainfall intensity for that area. The problem is that comes in millimetres per hour, okay, but we need litres per second. So therefore you times the catchment area by the rainfall intensity, which for Montmorency would be 195, and divide it by the number of seconds in an hour, okay? That gives you litres per second. So suddenly, this becomes, that's the formula that you live or die by, okay? So I think that's pretty easy. You just got to get it into your head. This square area times the rainfall intensity, which is in millimetres per hour, but I need it in litres per second, so I divide it by how many seconds there are in an hour. There's the example, 120 square metres at 180 millimetres per hour gives me a 6 litre flow rate, okay? We've already spoken about the 3 litre minimum, so we don't need to go there. And also, if you've got a T box gutter and one of them's 1.5 litres and the other's 5 litres, you don't make this one, you don't assume 3 litres for this one because it's actually combined. So you have to just, you forget about the 3 litre minimum and you add them both together, which will be beyond 3 litres, okay? There's a little example there, which is probably really helpful for you guys just to be aware of how to design a roof. It's the most simple way that we could possibly explain what's something which can be quite complicated, okay? So if you just run through that and familiarise yourselves with this kind of calculation, you suddenly discover that those roof areas add up to 7.8 litres a second. And once you have that number, you're in, okay? It's the ticket into being compliant. We've spoken about free flow. The charts that we have are done for 1 in 200, 1 in 150, 1 in 100, 1 in 140, which most of those in the Australian standard. The only one that's not is the 1 in 150. And the reason that's there is because of what we spoke about before. Would I put a box gutter? Now, I won't put a roof on at 1 degree because it's too close to the minimum, but I'll put a box gutter in at 1 in 200, okay? Which is the absolute minimum standard. Why not go, you know what? Guess what? I can have creep, deflection, all kinds of things happen in that house. Why don't I use 1 in 150? Because then I've got a 2.5 millimetre buffer on every metre. So, in a perfect world, we'd like people to be using 1 in 150. Most of the time you can get away with it, and unless it's a really big box gutter, which might make things difficult. So it's wise to not use minimums. Here's your charts, and we're just about to finish up here, but this thing here is an example of how to use a chart. Okay, you've got this in your handout. So we take that figure of 6 litres a second on the left-hand side. We come across to the box gutter depth, width, which is 300 millimetres. We drop down, and we know that that's 118 millimetres. Good idea to round that up. So 120 millimetres becomes the upstream minimum depth of the box gutter. And down the bottom here, if you're running at 1 in 200, which you can do, okay, you're gaining 5 millimetres per metre for every metre downstream. And so, this is how you can work out how big your box gutter section is. Now, those charts are just the Australian standards made more easy to read. okay? So you don't have to fiddle-diddle around with a whole bunch of calculations. So these things are available on our website. You guys have got them in the handout there. So it's a really good way to go. There's a 1 in 150 version of it. Okay, same sort of thing, and there's examples of how that works. So, go through, have a good look at this stuff, and you'll find that sizing box cutters becomes really easy once you know what the minimum upstream depth is. Okay. Same story with downpipes. All the downpipe sizes are there. You'll see that we've actually tested downpipe sizes as well below what's in the Australian standards because there was nothing in the graphs there. So even though they're allowed, there was no actual calculations. So that's a really good way of going, oh yeah, this is great, but I need is this 90mm downpipe going to be sufficient for the roof area that's coming into it? Same sort of story. You just got to get used to reading these graphs, and then life becomes a lot easier. It's a selection process. It's not design. Okay, we're not asking you guys to do design. We're just asking you to select the products with the right flow rate. That's the key piece of information. So all our devices are sized in the same way, so all of the information is available there for you guys to have a look at. Okay, so don't run. We're just going to show a couple of videos which you might find interesting of the products being tested in the rig in Clayton. And then we can head downstairs, have a look at it, have a beer, and guys, I hope that was really helpful. And you guys have got some takeaways there, and we can assist you in lots of ways. Our website's becoming really, really helpful. So yeah, thanks for your attention. That's really good.